The Bell telephone system brings you one of a series of programs on science. Man's effort to understand nature's laws.
Want to see an out-of-this-world true detective story? Well, sharpen your wits and hop on your magic carpet. You've got one, you know. Your imagination. Phantom invaders from outer space. Master keys to nuclear magic. Adventure, discovery, the greatest 50 years in the history of mankind. But how do we package all that into a show?
It's very simple. We ask your magic screen.
I have, but when it's blank up here, it's blank up...
The magic screen.
Boing. Maybe it isn't so blank up here. Come on, magic screen, come up with something.
Here we are back in Mysteryland, ladies and gentlemen, and man, oh man, have we got excitement. Great night, great night. Everybody's got a detective story candidate. Agatha Christie, Earl Stanley Gardner, Dorothy Sayers. Everybody's got a candidate as the crowd mills around the famous Academy of Detection Arts and Sciences. And no wonder. Being voted on tonight is the award. The Edgar, it's called, for the best detective story of the first half of the 20th century.
Best detective story.
Ed, any word from the judges yet? Take it away, Ed.
Can just barely see the judges. Boy, are they sweating. There they are.
This is an absolute bore. These writers.
Mystery schmistery. On the first page, I know who did it. who done it?
You all recognize the chairman, Edgar Allan Poe, whose Murders in the Rue Morgue won the first Edgar.
Nevermore, nevermore.
To his right, Charles Dickens, who gave us one of the strangest detective stories ever penned, The Unfinished Mystery of Edwin Drood. And on the chairman's left is Fyodor Mikhailovich Dostoevsky. And that golden skull you see on the table, that's the winner's prize, the coveted Edgar.
Of course. That's it. That's us. Gentlemen.
What are you doing?
Most honorable judges, we have an entry for you.
Another entry, huh?
What are you talking about?
The contest is closed.
Well, how can it be when we've got the greatest detective story of the last 50 years? The Strange Case of the Cosmic Rays.
Cosmic Rays.
Strange Case of the Cosmic Rays. An excellent title.
You realize, of course, the detective story has certain requirements.
Analysis, deduction, seemingly insignificant clues.
Right. Well, our story begins with a clue so insignificant, Mr. Poe, it wasn't even noticed for 100 years or more.
The detective story is literature. It must have scope.
Scope, he says. Jim, roll 3. Why, the Cosmic Ray case has helped to revolutionize the modern world. Look, have a look. Atomic power plants for the future. Atomic subs. Atomic planes. Radioactive drugstores. Isotopes for medicine. And hold on to your hats. How's that for scope? Well, gentlemen, do we qualify?
Theodore?
Yet. Science is for me a big bore.
A big bore? Why, do you realize that just while you were speaking, the criminal in our case fired 20 atomic bullets through your head?
Good. Holes in the head I like.
And you traced this criminal through that tiny clue you spoke of?
Yes. The story begins as an ordinary theft. Theft from this simple electroscope, a common instrument that's been in use to detect radiation for generations. It's just an airtight jar with an insulated metal rod, from one end of which hang 2 pieces of gold leaf. Now, normally, they hang straight down. Thank you, boy. But as every school kid knows, when an electric charge is put on the rod, so, the leaves become charged. Now, as to the detection powers of the electroscope. When radiation is from this piece of uranium, for instance, enters the jar, the air inside is broken up into charged fragments, some of which neutralize the charge on the leaves and cause them to fall. And the stronger the radiation, the faster they fall.
What is this, a schoolroom? Where is the mystery?
Well, the mystery is that when a charged electroscope was put aside, when no known radiation was around, the gold leaves mysteriously lost their charge and collapsed anyway.
The tiny clue.
So, is leaking a little electricity. That's a bank robbery?
That's just how science thought of it. Bank robbery. Roll 4. Now, imagine the charged electroscope as a kind of bank and the known radiations as thieves, bank robbers. Yeah, there you are. Depositors putting their hard-earned electrons into savings accounts. Wait a minute. That's no depositor there. That's Miss Ultraviolet Ray. She's one of the slyest of our robbers. Lift the electrons right off your back.
Drop up and have a joke sometime.
Don't you do it. There's a distant cousin of Violet's over there, Gamma Ray. Ordinary walls don't mean a thing to him. Wow, here comes a real tough bunch in from the hideout. The Uranium Gang. Those hombres have been in and out of that calaboose so often they go by numbers. 234, 235, and 238. I hope 235's not carrying what I think he is. You know, those boys are the atom bomb boys.
Help! 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 Sheriff! Robbery! Help! They went that way!
Put on more guards! This thievery has got to stop! Rebuild the bank! Put lead walls around it, 9 feet thick!
So with 9 feet around it, the electroscope bank became the Fort Knox of science. Not one of our robbers was sly enough like Ultraviolet.
Thank you.
Or persistent enough like old Gamma.
Thank you.
Or powerful enough like the numbers boys to break in.
No more breaking into my bank.
Help!
Hey, wait a minute. What's wrong now?
Mr. President, another robbery!
Brother, somebody has broken in.
Must be a phantom bandit. A phantom bandit? Get the town marshal, get the army, the navy, call out the Marines. He must be caught.
That is literature?
Well, it's...
The point we're trying to make, gentlemen, is that just a few inches of lead would shield any electroscope from all known radiations, even from the most powerful X-rays. But this new radiation, why, even lead walls 9 feet thick couldn't keep it from crashing through and collapsing the leaves. That meant that some unknown, super powerful, ghostly radiation was loose in the world.
Where did this phantom come from?
The first guess was that it came from some new radioactive element in the Earth. But how to prove this? A Jesuit physicist, Theodore Wolf, thought he had a way. Father Wolf reasoned, if the phantom radiation came from the Earth, the higher you got in the air, the weaker it would be, and the slower it would discharge the leaves of an electroscope. In 1910, the good father went to the foot of the Eiffel Tower. He charged his electroscope and then carefully measured how long it took the unknown radiation to steal the charge from the leaves. Then he climbed and climbed and climbed, and at the top, 1,000 feet above the Earth, he recharged his electroscope. Now, if the unknown radiation came from the Earth, his electroscope should have discharged more slowly. But it didn't. If anything, it discharged faster.
Father Wolf didn't know it, but his legwork was the start of one of the greatest chases in the history of science.
Other investigators, including Victor Francis Hess, decided that the Eiffel Tower just wasn't high enough. So in 1912, Hess borrowed a balloon from the Austrian army. Then he rose past Father Wolf's 1,000 feet, past 5,000, 10,000, 13, 14, 15,000 feet. There he charged his electroscope again, and he found that its leaves collapsed twice as fast as they did on the ground. At 3 miles up, the ghostly radiation, instead of becoming weaker, was twice as strong.
This really threw the science dicks for a loop. The Phantom Thief couldn't possibly come from the Earth, so where did he come from?
Gentlemen, please, we're on the air. All the network. Who gets the Edgar?
We are not ready yet. Put on a commercial. Go! Get out!
Yes, yes.
Your bandit is a sort of flying creature, then. A kind of atmospheric Batman?
That was the next guess, that the strange radiation originated somewhere in our own atmosphere. The argument was settled when a famous American scientist, Robert A. Millikan, took up the chase. Assisted by Ira Bowen, now director of the Palomar and Mount Wilson observatories, Millikan built an electroscope that would time and record the discharge rate of the leaves and then charge them again automatically.
This is kind of an automatic mechanical bloodhound.
And Millikan's talkative bloodhounds, reporting back from balloons 50,000 feet above the plains of Texas, and from the deep waters of 2 California mountain lakes, proved beyond a doubt that the rays could not originate in our own atmosphere.
But where were the rays coming from, then? The sun?
No.
Is bullets coming? It's easy. Mars.
No. The rays weren't coming from the sun, the moon, a planet, or any single star. Tell them why, Doc.
Well, because observers in every part of the world reported a most curious thing. The ghostly radiation was the same by night as by day, hitting each spot of the Earth continuously with equal force from every direction.
See, which meant they couldn't be coming from any single source. And so the amazed detectives were confronted with super rays whose hideout was the biggest ever imagined. The great open spaces of the entire universe.
Yes, and Millikan, recognizing the extraordinary nature of these rays, christened them cosmic rays.
It's becoming interesting.
What a pity. Real phantoms, and out where no one will ever see them.
Oh, one needn't see a criminal to know him, Charles. His dossier, fingerprints, footprints, methods of operation, mental quirks, often provide police with a more accurate picture than do the eyes.
A dossier on a ray?
That's exactly what the science detectives were trying to fill in. A dossier. Now, they'd already discovered the criminal's hideout. Merely the whole universe. All right, then. How about physical characteristics? Well, radiation can be either waves or particles. Were the rays waves, weightless energy like ordinary sunlight, or solid particles of matter, tiny atomic bullets?
To find the answer to that one, in 1929, 2 German science detectives, Walter Bothe and Werner Kohlhörster, rigged up a sort of a cosmic mousetrap.
Mousetrap?
I'll give you a quick version of the heart, at least, of their famous experiment with this modern equipment.
You mean how they found out whether cosmic rays were solid particles or waves?
That's right.
This I gotta see.
Now, this is a bank of Geiger counters. The 2 Germans knew that when electromagnetic waves like X-rays, ultraviolet rays, or gamma rays, waves go through a Geiger counter, only about 1 in 50 of the waves going through could make the counter click.
1 in 50?
That's right. While solid particles of matter, electrons, for instance, would make the counter click every time one went through.
Particles outclick waves 50 to 1.
That's just in one counter. Well, by putting 2 banks of counters, one above the other like this, and wiring them so that waves of particles have to go through both counters before they can produce a click, they had the answer.
They did?
Well, figure it out. Waves with a 50-to-1 chance of causing a click in one counter, 50-to-1, have about a 2,500-to-1 chance if they have to actuate two counters before they produce the click.
Worse than a daily double.
While solid particles going through both counters, produce a click each time one goes through.
Okay, particles have it by 2,500 to 1. But where does the mousetrap part come in?
Oh, the mousetrap is this thick slab of lead that's slipped in between the two counters. So, now this lead is thick enough to trap all stray earthly radiation and stop it from reaching the lower counters. But the hard-hitting cosmic rays go through it like a bullet through a cracker. I'll switch on the mousetrap, and you can determine for yourselves if the cosmic rays smashing down into this room right now are waves or particles. Now remember, occasional clicking, waves. Steady clicking, particles.
Particles. Amazing.
Yes, particles. What you are hearing are actual cosmic ray bullets, the same bullets that crash into all of us.
First-rate detection.
And a second entry for the dossier. The invader from outer space is a particle.
These particles is like breadcrumbs, dandruff, or what?
No, something far more fundamental than dandruff. By particles, they meant the incredibly tiny bricks of matter that make up all atoms. Sealing wax, cabbages, kings. They're all built of three fundamental building blocks, the lightest of which is the electron with a negative charge. And about 2,000 times heavier is the proton with a positive charge. About the same weight as the proton is the neutron with no charge. Electron, proton, neutron.
But which of these trons was the criminal from outer space? That was the question.
With only 3 suspects, it should have been easy to pin down the culprit.
Quite easy, yes.
Might have been, if a complication hadn't arisen.
Ah, complication. Good construction, Fedor.
What have you found out, Mr. Poe? That the particles discharging electroscopes and making these Geiger counters click were not the cosmic invaders from outer space at all.
What if you found out that they were the henchmen of the criminal?
Henchmen?
Well, maybe involuntary henchmen. They're really called secondaries. They're bits of air atoms shattered by the primary invaders as they crash into our atmosphere.
Which is the villain of your story? I assure you, readers have no such trouble identifying my villains. Take Fagin, for example, in Oliver Twist.
If you think of the character you're about to see as Fagin, maybe I can straighten you out. Look out, Tom. Now, there you see the Earth and its cloak of atmosphere. A constant rain of cosmic particles. Millions and millions and millions of them every second falls on the atmosphere. Now, let's take one particle and follow it down in slow motion.
And that is Fagin?
That's right. That's Fagin. He's entering the Earth's atmosphere now. Those round things he's passing are air atoms. The closer you get to Earth, the more there are. Now, he's bound to hit one pretty quick. Watch what happens when he does. There. Got a bad temper, Fagin has. See those little guys taking it on the lam? Those are the secondaries we were talking about. Dozens of them. Bits of air atoms kicked into violent action by a primary.
Ah, I see it now. The primary culprit from outer space is Fagin, and the secondaries from our own air are his henchmen. You see, Fedor?
I see nothing.
Oh. Right. And another item for the dossier. Fagin's dossier. His M.O., method of operation, he works through henchmen.
This becomes interesting. A mastermind operating through pawns.
Well, hardly pawns, Mr. Poe. The henchmen themselves were soon found to be incredibly powerful, possessing enormous energy and speed.
Additional entries for the dossier?
Yeah, for the henchman's dossier. Because now the science detectives found they needed a second dossier. And where do you think they got their entries for the henchman's dossier? Well, it seems that the henchmen leave footprints.
Footprints?
And they were detected by a honey of a device, a cloud chamber.
Cloud chamber.
See here, Mr. Scientist. Are you trying to tell us that invisible cosmic criminals leave visible footprints?
That, perhaps even we might see?
Yes.
Sure you can.
Anybody can see them, right in his own kitchen. Soft lights, Doc. Any kid can make this kind of a 2-bit cloud chamber. Look, first you take a piece of dry ice, then a large-mouthed jar. Set the jar on top of the dry ice. Now, it's well to put a piece of black cloth in the bottom of the jar so you can see the tracks better. Now, take a piece of cardboard and saturate it with alcohol. Any kind of alcohol will do. This that I'm using is just ordinary rubbing alcohol. Now, take a hot iron. Heat on top, cold on the bottom. Now you wait a few moments for the alcohol vapor to cool and settle. Now, let's flash a light through that. And there you are. Cosmic ray footprints. You can't see the actual flying particles, but you can see their tracks.
Much as invisible high-flying jets leave their visible vapor trails. Celestial footprints which reveal the jet's speed, height, and direction.
Incredible.
Oh, I must do this trick for Tolstoy. It will kill him.
I can't wait to try it on Will Shakespeare.
But it's my trick. I thought of it fast.
Fascinating. But the vapor tracks all look alike. How could the detectives tell which henchman left which footprints?
Oh, yes, indeed, yes.
Good question, Mr. Poe. White Stock. And the answer was simple but fascinating. A U-magnet. The kind kids pick up nails with.
As you probably know, Mr. Poe, between the poles of a magnet, there's a magnetic field as indicated by these lines of force. Now, the detectives knew that when a charged particle enters a magnetic field, its path is bent by the field and bent at right angles to the lines of force. Now, it's bent to the left if its charge is negative, and it's bent to the right if its charge is positive. Well, these scientific detectives reasoned, if they were to put a cloud chamber, this is a tiny model of a cloud chamber, in the middle of a very powerful magnetic field,
The footprints would curve.
Exactly, Mr. Poe. The cosmic ray henchman shooting through the cloud chamber would leave curved footprints. Then, by placing a camera here and photographing these cloud tracks, the detectives had an ingenious way of identifying the henchmen by analyzing their curved footprints.
This I like.
Now, for instance, as you'll see in these actual cloud chamber pictures, this particle had a negative charge because its track curves to the left. This track curves to the right, so its charge was positive.
These are pictures of the actual henchmen, aren't they?
Not of the particles themselves, but of their vapor trails, the footprints they leave behind in the cloud chamber as they're pulled to the right or to the left by the strong magnets outside the cloud chamber. When the detectives began photographing the henchmen's footprints in their elaborate cloud chambers, now equipped with an ingenious triggering system invented by PMS Blackett of England, GPS Occhialini of Italy, then measuring the amount of bending and the thickness of the tracks, they discovered some astounding things. The henchmen were traveling at unheard of speeds.
Speed? Wow.
Finally, from studies of thousands of cloud chamber photographs, the henchmen were identified.
And who do you think they turned out to be? Our old pals. Electron, proton, neutron. Those three building blocks of the universe.
Flying bricks of actual matter.
Just imagine, yes.
But remember, these energy-packed babies were only the henchmen. Think what superpower boss man Fagin himself must have.
But who was this master criminal?
Yes, who?
That was the brain twister. The sleuths had identified the gang, but not the leader. But since he operated way up high, an ocean of air lay between them and Fagin. How to get to him?
I'll give you 8 to 5. You'll never guess how they trapped him.
A woman, maybe?
Yeah, sort of a mother. To put the finger on Fagin, they used Mother Earth.
Now, just one procleata minuta.
Yes, Mr. Dostoevsky, they actually did use the Earth to find out if Fagin was armed, to find out if he carried an electric charge or was just a chunk of neutral matter.